Okay. Well, let me welcome you to the University of Tennessee Nuclear Engineering Department Seminar Series. Today's speaker is Dr. Ken Piety, who is a Vice President from Computational Systems Incorporated. That's a local high-tech firm. He is one of the founders of the firm. He is a graduate of this department, receiving a PhD in nuclear engineering in 1975. And the title of his presentation today is The Impact of Leadership and Product Champions in Technology Development at CSI. Ken, welcome.
Thank you. I don't know if that's what I'm going to talk about or not. He asked for a title, and so I had to give him something. Are all of you here nuclear engineers? Is that nobody from any other curriculum?
We have a few.
A few others?
Yeah.
And, I see. There's a couple industrial engineers here. And Mechanical, okay. Yeah, I recognize a few faces there. And why do you come to this? He wouldn't tell me that. I tried to figure out what this was all about, and why do you come to this seminar?
You really want me to answer that question?
I think I know the answer. You come because he requires you to come, right? Okay, well, that's what I figured. Is there anything that you would like to get out of this? Do you have any idea what I want to talk about, what I could tell you, or what good I could do you from you listening to me? I'd like to do something that was useful to you, and I can tell you about CSI, and I will tell you about CSI. I am a graduate of the Nuclear Engineering Department, but I haven't done much with nuclear engineering since about 3 years after I got out of school, because I worked with Oak Ridge National Laboratory for 3 years, I think, before I moved over and began working in commercial industry. But it is the things that I learned here in the Nuclear Engineering Department that I've continued to do all my life. So the education stood me well, although I haven't stayed in the nuclear field. And I don't know if any of you, we do have customers of our company. Probably most of the nuclear plants are our customers, but we don't do what I would call nuclear-related business per se. CSI is a company that was started in 1984-85 time frame. It was founded by two people who were graduates of the Nuclear Engineering Department, myself and Ron Canada. Ron was really the founder of the company, and that's a little bit of a misnomer. He wasn't really a graduate of the Nuclear Engineering Department. I don't think he ever got a degree here. He did. Oh, did he? Okay, all right. I keep teasing him. I wasn't sure he ever got his degrees, because he kept going from, he would get finished with something early and move on to a master's or something, and I accused him of never really finishing anything he started. But Ron was a nuclear engineering graduate also, and he and I met each other and worked together in a company called Technology for Energy Corporation, which was started by two of the professors and another graduate of the Nuclear Engineering Department. It's a very inbred community here. And I got to go back to work for Dr. Jim Robinson, who was my major professor that I did my dissertation research under at Technology for Energy Corporation. Tables turn. This is something you might keep in mind, professors. Dr. Robinson works for me now. Just throw that little point out, because, I know that some professors have a sort of godlike complex, and they feel like they have your life in their hands. But you remind them that the worm does turn on occasions, and that someday they may work for you. And Dr. Robinson and I get along very well together, and very compatible. So he treated me well, and I try to treat him well. At any rate, CSI is a company that was started in about 1984-85. We have as our mission statement, what's written up here on this slide, says changing the way the world performs maintenance. And helping change the way industrial plants, petrochem, power, paper and pulp, all types of heavy manufacturing industry, the way they do their maintenance in their plants has been what we've been all about. We really started off as a vibration analysis company, and that's part of what I learned here in the Nuclear Engineering Department. Actually, it was neutron noise analysis, and some of you may yet even be working on neutron noise analysis, but when you analyze neutron noise, since it's one of those signals that's got a lot of squiggles in it, you like to do FFT and other signal processing type of activities. And so that's what I was doing my research on, was trying to find automated ways to detect reactor anomalies using neutron noise analysis. Found out it was a little difficult to play with reactors too much. They don't like you to go in there and introduce faults and do a lot of other things. When I left here, I'd done my dissertation out at Oak Ridge National Laboratory, and I went to work out there and continued working on that area. But found I was working in the fast liquid metal breeder program before Jimmy Carter gave it the thumbs down, and the funding for that project kind of came to a halt, and I thought, gee, we're working on something that's pretty valuable here, but, political winds are going to send it down the trash can with little or no reason applied to the merits of what we're doing. I'm not sure that's an industry that is as stable as I want to be in. I think I'll take the things that I know how to do, and most of what I'd ever done experimentation on was rotating machinery, because you could do things to rotating machinery and it had dynamic signals, and it was hard to get them to do things to reactors that were very serious. And, I did a lot of time out at the Heifer. I put my hours in out there watching it go through its cycles, and nothing changed. And I've been other places and watched it do, and nothing changed, and that was kind of boring. But you could take rotating machinery, and most of the time somebody would let you screw it up somewhere, and you could watch it actually do something that was wrong and really see if what you'd worked on would catch something. And so that's kind of how I got into rotating machinery, and there was an opportunity to do a Department of Energy study on the advanced BWR-6. It happened to be in a really hot spot in the world called it's Grand Gulf Nuclear Station, and it's in Fort Gibson, Mississippi. I don't know if any of you have had the pleasure of visiting that plant. I've been there many times, till all hours of the day and night, and it's a very pleasurable place to be. But our job was to apply an advanced diagnostic and surveillance system to the balanced plant equipment at that BWR-6. And I worked on that project for several years, and as I said, became fairly infatuated with the idea of trying to help people find problems in rotating machinery for the purpose of trying to prevent those problems or schedule their maintenance. So that's how a nice nuclear engineer like myself got into rotating machinery analysis and then more into the mechanical side of the world. So even a longer story about how a nice guy like I got into nuclear engineering in the first place, and I won't even go into that one. I didn't even know what a nuclear engineer was when I came up here to UT, but they taught me. Our job, though, has been trying to redefine maintenance. In the United States, there's about $200 billion that are spent on maintenance each year, give or take $1 billion or $2 billion. And it's suggested that probably a third of that money is wasted, that it's being applied in ways that's non-productive and is bringing no benefit to the industry. So if you take that, that's about $60 billion that is probably kind of going down the tubes. And that's a reasonable target of interest for industry and for America to try to save. Because if we could change the way we're doing maintenance, perhaps that $60 billion could either go to profits or to something other useful activity. Most of maintenance activities in the past have been oriented towards run to failure or reactive types of situations. The philosophy in a lot of plants has been that you cannot do anything about maintenance. It's just going to happen when it happens. You wait till things break, and when they break, then it's a fire drill, and you try to fix it as fast as you can. And a lot of times what they do is they get very good at fixing it fast. And when they've done that, then they feel like they've solved their problems. And I've gone into plants and asked them and said, have you got any maintenance problems or issues like that? And they'd go, no, we don't have anything that's a problem here. And I think, goodness gracious, I can't believe in a big plant like this you don't have any maintenance issues. So you just get to talk with them. Well, there's this set gear set over here, and yeah, it goes down once a month, costs us $250,000, but it's not really a problem. We know how to fix it now in an 8-hour shift. And you think, but what about the $250,000? And, once a month seems a little often for it to be going down, but we can fix it fast. And, so you get people in this kind of a mindset. The other type of maintenance that people have done a lot of, and this again has really occurred more so in the last 50 years, is preventive maintenance, and most of you would know what that is, and that's basically doing things to equipment before there's breakdowns on a time schedule or a use schedule basis. The first maintenance I'd kind of call hysterical maintenance. This is more historical maintenance. And again, you've got to plan to do your schedule in a very conservative way if you don't want to have unexpected outages, which is the problem with reactive maintenance. And if you schedule it conservatively, so let's say you don't get surprised very often, then you can pretty well guarantee that you're maintaining every piece of equipment in your plant well before it needs to be maintained. And further than that, you're liable to break it when you do. So the impact of both reactive and preventive maintenance has always been that people are doing too much maintenance and they're doing it at the wrong time. Again, this is where that $60 billion worth of waste comes in. EPRI did a study that showed power plant improvements of availability in the neighborhood of 19% by applying advanced maintenance activities. EI DuPont determined that they could that was the largest controllable expense in their corporation. Most industry that we deal with, their maintenance budget represents somewhere between 5 and 13% of their total sales, which again, if you do the math, turns out usually to be a pretty good sized chunk of change. And helping them save up towards a third of that means real dollars to the bottom line. We deal, as I said, with all types of industry, and typically if you look at somebody like a petrochemical plant, they're going to be the kind that they're putting 13% into their maintenance. If you get into the lighter industry, some of the ones that are oriented more towards like food manufacturing and things like that and have less heavy equipment, typically be somewhat less into their maintenance budgets, but still a sizable amount of money. And again, the problems are you get unexpected downtime, interrupted production schedules, and increased cost. CSI championed an approach into the industry which was called reliability-based maintenance. That's a trademark that we trademarked. We basically use it to say it's advanced maintenance procedures which allow you to optimize the utilization of your personnel and your assets to produce the highest quality product on time at the least life cycle cost at the right quality. And it's a balance of strategies. You still need preventive. There's a place for that. There's probably even a minor place for reactive. If you've got something that really doesn't have any impact on your plant and it's spared or whatever, then maybe letting it run to failure is an okay scenario. But you need to supplement that with predictive maintenance technologies and proactive. And CSI has made a living as a predictive, proactive maintenance type company. And this is all done by utilizing computers, microprocessors, electronics, and computer software to collect the vital signs of machinery and to analyze that and to assess the health of that machinery. Much as a doctor would do for you if you went in for a physical, he's going to take your pulse and your temperature and check your heart and listen to you breathe and maybe a few other things that are less easy to talk about here in public. If you don't like to talk about that, he'll do to you to try to see what are your vital signs and get a sense of your rhythms. And if you've got issues, and he may ask you to go and do even more extensive tests, electrocardiograms and other things that would more closely approximate this. Well, all machinery, that's failing or has impending failures is going to give off some kind of signal of those impending failures. We don't always know what all the signals are, but they all give off something. And the goal is to make measurements of their dynamic performance, their vibration, of their temperature characteristics, of the ultrasonic sounds coming off of the equipment, of the electromagnetic effects of the equipment, the lubricating fluids in them, much like they might analyze your blood, and to look at all of these symptoms of or characteristics of the machine, and from that assess what its health is. People have been able to do this for a long time, but it's usually required fairly high levels of training, and it's required fairly expensive equipment, and it's been fairly inefficient to do it. And I guess CSI has made a living, so to speak, by making it possible for the typical maintenance personnel to go out and collect large quantities of this data very efficiently and analyze that information and determine what the health of the machines are. Most everything we do really centers around that. We didn't invent vibration analysis, but we made it practical for use inside a plant so that a typical maintenance guy can go around and do measurements on 500 or 600, 800 points in a single 8-hour shift that used to be, and I've done quite a bit of it, we would pile a bunch of equipment into the back of a van or something and go set it up somewhere, and in 8 hours we might have got information on 2 or 3 or 4 points or 5 points, and then come back and analyze that data for a week. But what we have tried to do is, using what microprocessors and PCs and what can now be built into instrumentation, take a lot of the smarts of what people understand how to do and really try to put that into a form where the person using it doesn't have to be, he doesn't have to understand everything he's doing to do something very useful. And we've done that. We've championed the idea of an integrated family of products and services. All of this is built around a software platform, but that includes vibration analysis, tribology, or lubrication analysis, both portable and continuous vibration monitoring, ultrasonics, motor diagnostics, and corrective technologies like laser alignment and balancing. Vibration was where we started, and again, that was kind of our picture of the universe in 1984-85. We thought if we could help solve that problem, that we would at least support our families and not go hungry, and in my case, that's a fairly good challenge to support just my family and feed them. But so I would say if you looked at CSI in 1984 through 87, we were primarily a vibration analysis company, and we created portable instruments that look like some of these that are sitting around on this. I guess you're supposed to not use your fingers, aren't you? It's kind of like eating.
Use whatever you want to use.
Anyway, we have a family of various vibration analyzers, and those analyzers are fairly powerful FFT processors that you can take computer software, set up a picture of your plant, of what machines you've got and how you want to monitor it, create routes, and download that information into these portable instruments, and go out, and by the maintenance man, it leads him to the right machine, and if he'll touch the right point, in a few seconds it will pick up information about that machine, which he may or may not be aware of what he's measuring, put it into the memory, and he walks on to the next point. And usually in, I would say, less than 30 seconds he can cover a machine. It's usually 2 or 3 or 4 or 5 seconds per point. And normally they'll monitor anywhere from a few points to 10 points per machine, and then move on to the next machine. And again, he walks through the plant, comes back, downloads that information into the PC, runs some programs to analyze it, and from that has an indication of which of his machines are in good shape, which ones are in a suspicious condition, and that he needs to look at or do further analysis. And then there's tools available to help him do that analysis. And that's how we had our rise to fame. CSI started in '85. Ron almost starved to death while he was trying to pay my salary and a few others. We got through a fairly rough first year. Our sales went from, I think, $200,000 to $600,000 to $1.8 million to $4 million to $8 million to $16 million. And I guess in 1995, I think it was, we went public at about a $45 million company. We also had a program going on, though, where we interacted a lot with our customers, and part of that program was to try to understand what the customers who were being the most successful did. And so we sponsored what was called at that point in time the Predictive Maintenance Program of the Year, and customers competed for that. And part of the competition was they had to fill out questionnaires, we did plant visits, and evaluated and assessed their programs. And that led us to understand what kinds of things they were doing in the more successful programs and what kinds of things were not happening in the least successful programs. We learned a lot from doing that and really came upon the feeling that vibration in itself was good and particularly useful for rotating machinery, reciprocating, but you needed other technologies to assess other types of equipment like electrical or piping or other types of things that you have in your vessels, reactors, and other things that you have in your plant. You need other technologies because vibration doesn't cover all of the fault types or all the failure modes that various types of plant equipment manifest. And so we embarked on a path at that time, and up until then, I would say most of the research was pretty well directed by Ron or I. I've done about every job in the company, but I've been the director of engineering for a long time. I don't know, maybe since 92 or so. But most of the projects, either we were leading them or conducting them. At that point in time, there was a need to kind of expand into other areas. We needed to develop instrumentation and techniques and motor analysis, we did laser alignment and balancing equipment. We developed an analyzer for oil analysis, and we did some things in infrared thermography. Ultimately, did some stuff in ultrasonics, and so we began to develop these other technologies. And it was a little bit difficult for me to do everything. Besides not being smart enough and not having enough hours in the day, it just didn't seem like it was a wise thing to do. So we needed to expand engineering. Our engineering group right now is about, I don't know, somewhere 70 plus people and has about a $6 million budget. And I have broken that. What I tried to do in order to keep what I would consider sort of an entrepreneurial attitude in the company, I'm a little bit of a maverick, and I don't really have, some people by nature are very administrative and others are not so much that way. I'm not so much that way. And I always tried to lead engineering more by leadership rather than by management. And I don't know if that makes, if you understand the difference between the two, there are a lot of people that don't, and many companies, you know, they'll try to manage the process. I just tried to lead the process. And what that means to me is it was my job to serve the people that I worked for, number one, and to try to empower and enable them to be effective and to enable them to succeed. Number two, I tried to set the example by I worked harder than all them. I mean, I've always been the person who worked the most hours at CSI, not because I couldn't have said, you're going to do it with me, but I felt like I needed to set the example by how I was willing to invest myself. And there's a certain amount of emotional commitment and involvement. Now, I had that because I was part of the owners and part of the founding force of the company, but I felt like for CSI to continue to succeed, I needed to infuse that type of attitude or view of life into the other people that were going to be doing research. And it's not necessarily easy to pass that on to people. I mean, if you're an owner, you have some financial interest at stake, although it really was never the finances that drove me. The fact that we ended up making money out of CSI, I think I feel very blessed by that, and I appreciate the money. But I would have done what I did if I had not made. If I was poor today, I would still have gone back and do what I did. I wouldn't change what I did. CSI in those days was a phenomenal place to work. I mean, everybody, the vision that we had before us of trying to change how the world did something, feeling that we were working on something that had real value to people, having a real commitment to wanting to see our customers succeed and provide value to them, having people that were, I mean, as a company, we really had a tremendous team spirit and commitment to bringing that to pass. It was the most fun place I've ever worked. I mean, I couldn't think of being a place I would pick to be with. I've worked for General Electric and Oak Ridge and maybe a half a dozen other companies, and I don't have anything bad to say about them. But the atmosphere and the environment of working in a place where a team is really pulling together and really focused upon a vision and a goal that's in front of them is really a stimulating environment. I mean, I just really can't it's difficult to describe to you. But I wanted to try to pass that on to the other people, and so I came upon creating what I thought was a good idea. Again, history has yet to speak, I guess, on it, but what I call product champions. And my intention was to foster small groups of engineers within our engineering department that would take ownership of that technology area. And by that, I mean, I wanted to try in their mind to sort of set them off and say, you're like another little company that's starting just like we started in vibration. I want you to take your technology area, and I want you to foster that and to help grow it up into a business. And I told them their success or failure in the company depended upon how their business area succeeded or failed. Not every engineer is capable of doing this. I mean, I tried to be relatively selective about the characteristics of the people who did it. I mean, they needed to be technically competent people, and that was obviously a requirement, but that was by no means the only requirement. They had to be people who were willing to really emotionally commit and buy into an area and let that become something that they had a vision for and that they were willing to both promote and kind of commit themselves to it, live it, eat it, sleep it. And a lot of people don't want to do that. They want to come to work, go home, and not have it impact them too greatly. I mean, they've got 8 hours to fill up, and they want to fill that up in the least obnoxious way to themselves. And there's nothing wrong with that, and there's a place for people like that in companies. But that's not what I was looking for as a product champion. I was looking for somebody who had somewhat of an entrepreneurial spirit, and again, could look at this as being his own company almost. And I wanted to keep the team small so that they could kind of grow with the team. And I told them, it doesn't matter if the product is failing because of sales problems, training problems, customer support problems, technical problems with the product. That's your problem. And, yeah, I know you're not in marketing, but you better go fix the marketing problems. And I know you may not be in sales, but you better help figure out how to help the salespeople fix their problem. Not because I was trying to give them something that was impossible to do, but because I wanted them to take ownership and accept responsibility for the success of what they were trying to accomplish. Not just that I went and I worked on the technical development, we did our part, hey, if it fails, that's not my problem. I mean, I've made a good, electronic instrument, or that software I wrote, that's fine. I don't know what the problem is with people selling it. I don't know why those marketing people can't market it, and, I saw a few people complain about we don't train them well and the customers aren't being supported, but that, I'm in engineering, and that wasn't good enough. And I wanted them to try to infuse into their product area the same kind of leadership. And again, as I said, they didn't have management responsibility where they could reach over into marketing and jerk people around and fire this guy and reassign that guy. They had to exert leadership. And that's different, like I say, from management. They didn't have management responsibility. But they were highly empowered individuals. They had my support, and I was at least second in the company. I had the second voice in the company, so they had some authority by association, and CSI was an engineering-led company. And so these fellows' job was to go into the marketplace, study, and they were assigned areas like, say, motor analysis, to study what kind of instrumentation was there, what kind of techniques were being used to analyze motors, go spend time with customers, find out what those customers needed and why they were having problems with motors in their plant, and to, basically come up with ideas and thoughts about how to solve those problems and research them and ultimately come up with instruments that would solve those issues. Now, that's a reasonably good-sized challenge because you're starting really from the not even knowing what the problem is to carrying it through to a conclusion. And we only needed, we needed to do that in 2 or 3 years, not in 10 or 15 years. And you could easily spend 10 or 15 years doing that kind of thing, but I didn't want to give them that kind of time because we needed to make money and succeed and survive as a company. And it's hard to be a company if you don't make money. Eventually somebody comes and nails your door shut. And my job in all that was basically coaching them and mentoring them. It would start off with where they would be, I would try to help them. I would go do what I just said with them. We would hold hands and we would go to plants and we would get literature together and review it and talk about it. And we would go through all these processes trying to understand what was the need of the marketplace, and we would go, if we saw something that we thought was important, we'd go up, we went up to Penn State once and licensed some technology up there from some sharp professors, and turned out that wasn't as good a technology as we thought it was. We made lots of mistakes. I mean, not everything we tried worked, and as I said, my job initially was I was going to try to kind of hold their hand and lead them to try to reproduce the process that Ron and I had reproduced in establishing the vibration business, and then ultimately attempt to wean them so that hopefully they would be better at it than I was. In their area, they would be more capable and smarter than I was, and that they would be able to lead it and independently establish that. And to keep them into smaller groups so that it didn't become where their main job in life was managing people and pushing numbers around, and they were so busy with processes that they couldn't be creative and create businesses. So that model was something I established at CSI. It was pretty unorthodox. It might not sound particularly unorthodox, but that's not the way most companies do it. The way most companies do it is there's a marketing department, and the marketing department establishes what the customer needs are, and they tell you what it is that they think needs to be built, and they may give you a specification, and engineering's job is to kind of go off and build it, and engineering builds it, and then they throw it over the fence, and somebody else's job is to sell it and train on it, and the engineers may hear about some of the complaints and may never even talk to a customer or know how the product's even being used, or if it's being successful or not successful, except complaints or something that may get filtered back to them. And again, as I said, my goal was to absolutely uninsulate these product champions and their teams from their customers, and to get them with their customers, understanding what customers were doing. I've always been absolutely of the conviction that if you don't understand what your customer does better than he does, you can't serve him well. And so you need to be in his britches with him. I mean, you need to be in his plant. You need to be understanding what he's doing. And what you'll find out is if you watch him, you'll learn a lot from him. I mean, you'll learn a tremendous amount from him. And you'll see things that he's doing that because he doesn't understand what technology can do, he doesn't understand how he can improve his situation or how he could solve a problem. He'll find ways to solve. They are doing their job, so they have learned to cope with the situation, but they haven't found optimum solutions. And a lot of times they've built very inefficient processes and very inefficient mechanisms, or very unprofitable mechanisms for solving their problems. So, if they have something that breaks a lot, they'll build a fixture that helps them fix that thing very quickly using the fixture rather than trying to get down. And you may be able to see, well, I can show you how to solve that problem and get rid of it. Or there's a root cause under this, and why do you keep doing it instead of trying to figure out what the root cause is and removing the root causes that are causing this? There's dynamic forces, thermal forces, friction forces, chemical forces, contaminant forces, electromagnetic forces that are behind these problems, and most of them are able to be discovered with the right set of measurements and analysis. And so our goal has been to take people who are bright and who are willing to be personally committed to a business area, and to let them study and become experts in that area, and to develop products based on their knowledge and their understanding of what their customers need. It's been something that I feel like has worked well. Not all the areas at CSI, though, have been none of them have been as successful as the vibration area. I don't know if that's because of the products or not. I felt we have created the best-of-breed products in a number of areas, and those products have not achieved the success that the marketplace could have afforded them. Let's say, what I mean by that, let's say it's a $20 million market, and I figure from the best-of-breed product that we should take 30, 40, or 50% of that market over a period of time. And if we only take 5 or 10% of it, I don't feel like we've succeeded. If our product truly is best of breed, now you being best of breed and making other people understand that, and handling, there are a lot of issues out in the marketplace besides how good your product is. I will warn you that if somebody has been reading Ralph Waldo Emerson or Thoreau or somebody like that, and they've told you that the world will beat a path to your door with the best mousetrap, forget it. It will not beat a path to your door. You can have excellent products, but if you can't promote and market and sell those products, you will fail as a company. I mean, that's just what will happen. It takes good products, but that is not sufficient. It's necessary, but not sufficient condition to succeeding in business. And I will say that's one of the characteristics of my product champions. It was necessary that they be technically competent people. But if they weren't able to be promotional people, if they didn't have the right character qualities, it wasn't a sufficient condition that they be technically capable. And if I had something to pass on to you today, I guess that's what I would probably pass on to you, which is you're here getting technical excellence, I hope. I'm sure all of you are doing that, aren't you? Okay. But the real issues of probably determining whether or not you succeed once you get out of here, probably a lot while you're here, will be more character quality issues than they will be technical excellence. One of my best people, he's one of my best product champions and one of my best software people, I hired from putting trailer hitches on out of U-Haul at $5 an hour. That was about 25 years ago, 20 or 25 years ago. And he's one of my most capable and best product champions. And he has no real formal engineering education, although I have encouraged him to go back, and he has done a little training since then, but that hasn't been what's impacted him. But he is a learner, and that's a characteristic that we certainly found that, you don't quit learning, and he was unwilling to say, all I'm going to ever do in life is put trailer hitches on it, U-Haul it, and given an opportunity, he was willing to apply himself and pick up the skills he needed because he had the right character qualities. And some of the character qualities, I've had some very good people that have not been successful at CSI because of the lack of the character qualities and the interpersonal skills, and had some people that were, I would say, probably weren't the smartest people that came at the top of their class who've been very, very successful because they did have those qualities. So I'd encourage you to not see your education as an entitlement or as a end of the process. And I hope that even as you're doing your education, you're learning those character qualities of diligence and persistence and commitment. I assume that the educational process is drawing that out of them. But those will do you well as you go into industry. And I would encourage you to learn the difference between leadership and management. Management is a needed function in industry, but I'll tell you what, it doesn't supplant leadership. And we were bought 3 years ago by Emerson Electric Corporation, which is about a $13 billion corporation. We sold our company to them, and they are an extremely well-managed company, but I don't think they understand, again, and this is not to be critical of them, they are a very well-managed company. I'd give them highest marks in that. They have the unparalleled record in American industry of having 33 straight years of every quarter having increased earnings and increased sales without a single quarter failures in 33 years. No company in America has ever done that. And they're well-managed, but they're having a heck of a time trying to run CSI because there's a difference between manage and leadership, and they don't fully, and it's been difficult for the people at CSI to make that transition. It's a two-way street, but that's what I would impart to you.
Okay. All right. The floor is now open for questions and comments. Dan?
Back to the early stages of the company when it was just getting going. Is there anything you do different or anything you feel like the company has done different?
Well, most of the things done back in that time were probably done out of necessity. We had almost no funding. We got some seed capital of about 100. Ron started the company originally sort of as a computer consulting company for about a year. I joined him. I was on his board, but he used to work for me. And I was on his board. When I joined him, we licensed some products that he and I had developed and patented at Technology for Energy Corporation, and changed the direction of the company. We were a very underfunded company. I think he had savings that he had put into the company that by that time were gone, and we had about $150,000 that we got from an Oak Ridge seed capital type company, and that was what supported us while we came out with our first products. And like I said, mostly during that time there was a lot of sweat equity, a lot of long days trying to make our products reality. So there are a lot of things that, it's hard to say how creative or how strategic you were. You were probably more responding to you did whatever you had to do. Whether it was filling Coke machines or painting things or moving, every job was your job. The start of the company, I don't know that there's a lot that I would do different. We came into the marketplace when there was 3 or 4 major players in our marketplace. One company, Bentley Nevada, was about a $150 million company at that time. There was a well-established company that did portable instrumentation called IRD that was about a $50 million company, and several startups that were $2 or $3 million that were high-tech companies like ourselves that were ahead of us. And we came into the market the last with the least funding. And I don't think it was by God. I think God blessed us beyond what we deserved or what we had any reason to say we should have achieved by our own results. But so I'm not standing up here saying, boy, we were so smart, we figured it all out. But we were, ultimately now we're the dominant player in the marketplace as far as that industry, and several of those companies have changed hands, and so we came into the market with the last, with the least, and now are I'd say the predominant player in that marketplace. So it's a little hard to quarrel with. And our rise was pretty rapid. I think when we went to multiple technologies, we could have been a lot more creative. I think those technologies were dwarfed by our success with vibration, and we should have been able to be much more successful in those areas, and we could have been a $100 million company with no trouble had we been. But we produced modest success with those technologies. We produced some good products, but modest success in the marketplace, and a lot of it had to do with many times a company finds it's successful with selling a certain class of products, and its success it's difficult to get outside of its success, and I think that's what hit us in those product areas. We found it so easy to sell vibration equipment, and our vibration equipment was so good that why would our salesmen want to sell anything else? When they could go and slam dunk somebody with a vibration, instrument and make a good living. So we had some troubles, I think, adapting to that. Otherwise, I'm fairly pleased with what we accomplished.
What do you envision as the technological advancement in the next 5 to 10 years?
Well, a lot of where things are at right now in the industry is that where there's a program that's got a good champion, that program is very successful, and they can identify lots of savings, but it hasn't been built into the business operation of the plant. And so, they'll say, I'm saving $1 million here in vibration and $2 million here in lube analysis or infrared thermography, and so you add it all up, and it's $6 million for this year's savings. And they do that by saying, well, here's an incident I found, and that would have cost the plant this much, and I found this, and it would have cost the plant this much, but we averted it, and the downtime that was associated with that. And I think those are good numbers, but they don't show up at the bottom line a lot of times in the profitability. So this 30% of this $60 billion that you want to see on the bottom line is getting re-spent. The maintenance organization is a very momentum-driven organization. They're made, to spend the money that they're given. If they don't, they're not going to get it next year, so they're going to want to spend it. If they don't spend it that way, they'll spend it another way. And the money that you averted from operation is hard to see sometimes. You averted it, so you don't see it. And there's a lot to be done with changing the culture and the process, and there's a big push for services, and a lot of what we're doing today as a company is trying to help some of our customers. We've always had services. We've always been involved with our customers. But there's a real big move for outsourcing going on. And I think the initial champions that started the programs and were successful got promoted. A lot of the people that have taken over don't have the same buy-in or the same skill set. And people are coming back to us going to help us run our program now. And I think there really needs to be a partnership between companies, the industry, and companies like ourselves to ingrain this into the fabric and to get it into their business metrics and a lot of other things. That's on the process and business side. On the other side, in technology, there's a real need to improve and automate things still. Expert systems are still needed. They resist them in plants. That's a story in itself, and I could waste your time for 30 minutes or so telling you about that. But they resist that in plants. And other time savings mechanisms need to be done. A lot of it right now, we've got enough technology that it's more than people can use. If there's any problem that CSI has had, we tend to make over-technology products. We'll take something that's simple and we can put a lot more technology in it than the way you do it now, and we'll try to hide that by giving them simple ways of doing it, but we still got technology that's kind of oozing out all over it, and sometimes the customer that's just, he's wearing a tool belt and his pants are dropped a little low, he really doesn't care about the technology. I mean, he just wants to solve the problem, and we're really impressed with our technology, so we like to have it kind of oozing out here and there. And there are things we could do to make it just more practical for them. A lot of the advancements right now could be done just in terms of the way, if you could speed up data collection by a factor of 2, I mean, that's worth lots of money. And it may not be any technology. We're already using DSPs that have 10 kilohertz plus real-time rates. I mean, that's when I started working in this area, only the military didn't even have that kind of power that we have in our instruments today. And so it's not, we're not going to process the data any faster. Now, we might be clever about how we process data but there's a lot of things like that that can be done to speed up and make them do more with less, because industry is, like always, demanding that, you did it with 3 people this year, try to do it with 2 next year. And data harvesting is another thing that needs to be done. I found it extremely hard I kind of had a pretty influential position in our company, and it's still been pulling teeth to try to harvest data that's laying there for the taking. But if the serviceman's job is to be 80% utilized, not to promote the technology, getting that data out of him is trying. And there's a tremendous CSI that's an area we have failed as a company. We could have harvested a lot more data that would have improved our knowledge and other people's if we had the time and energy and willpower to do it. Tom?
Ken, over the last 5 or 6 years, I've had the privilege to see you in action, and I really admire what you've done and what you do. And I also appreciate comments you made about leadership versus management. The question I have is, if you could go back to the beginning and look at your education here. We educators are trying constantly to improve the product of our students. Is there something that could have been added to your education, and when you look back now, that would have helped you become this overall leader that you talk about now? Is there something else that could have been layered onto your education that would have made it easier or better?
Well, I guess since most of the people that educated me aren't still around, it's easy to...
Not necessarily technical.
I understand that. I'm teasing there a little.
You want me to step outside the...
No, that's not... No, Dr. Pasco and a few of the others. Actually, this used to be my office, guys. It's not the whole room. I had a little corner over there, but this used to be my office only about 20 years or 25 years ago. I almost got out of engineering after I graduated. I was a pretty gung-ho. I really didn't know what an engineer was when I came up here, and probably I was very interested in math and science, would have probably gone into physics, but some counselor here, they didn't have nuclear physics as a easily identifiable. It was a subset of the physics department. Somebody said, well, nuclear engineering is about the same, why don't you do that? And I said, okay, it's all right with me. So I went into engineering. I'm glad I did, but not with a lot of knowledge. I don't think I ever met an engineer growing up. Nobody in my family was, and so I don't come from any kind of, and in Middle Tennessee, in Murfreesboro, where I grew up, if there were engineering organizations, I think they would have probably been civil. But anyway, I liked math and science. My undergraduate education was a good one, and I think math and science-wise, challenging, stimulating, and I enjoyed the courses. And when I got out, I went to work in California at the nuclear division of General Electric, and I was pretty disappointed there. And that's what almost got me out of engineering. Probably that combined with other interests I had, because I was preaching and pastoring the church here in Knoxville while I was going to school. And after I worked for General Electric for a year, I thought I could have done this with about an 8th grade education. If this is what engineers are doing, maybe less, I don't think I want to be an engineer. This is about to bore me out of my mind. And the only things that I'm doing that are interesting are the things they don't know that I'm doing on my own. And so I'm not, this is the way it is. I hate this. And then I went to work in an inner city ministry for a year, and I really liked it. And I thought, boy, engineering is just not where I need to be. So the nuclear engineering department rescued me, and I came back here and worked for them for a while, and was trying to figure out a way to fill up a few years of my life. So I got a PhD, and that's what got me back into engineering and into this particular area. As I said, the education, and I don't have any real complaints. I think I could have, if I'd had more practical involvement in plants and with people that were engineers and with what they were doing, that would have stood me a little bit better and maybe prepared me to know more about what I was getting into. And maybe for some of the people, their dads here are engineers, or maybe they didn't need it. But after the end of my freshman year, Charles Weaver, who was the head of the College of Engineering at that time, was going to do me a big favor and get me an engineering job, and going to get it for me back in Murfreesboro, because I was poor and I couldn't afford to live anywhere but back at home. And so he got me a job at the General Electric plant that made small motors back in Murfreesboro. And so I went there, and I walked in the first day, and they said, "I'm here to do engineering work, And they said, "Oh, that's great. We don't have any engineers here, but we can let you get out on the assembly line and help us make motors and clean things out and do stuff like that." And shortly thereafter, the plant went on strike, and I had to go through strike lines. But I spent the summer, taking my hand through the oil pit and tearing all the little metal fragments and the thing and scraping it out and dumping it into the bucket. So, as I said, I wasn't really sure what an engineer was exactly. I just knew what the engineering education was. And so I don't think I was probably as prepared to understand what would it mean to be an engineer once you practiced it. And I don't know if that's your job to show me that, but it would have probably helped me had I known that.
One more question. Wes?
They're discussing this dual MBA program where you get an MBA and your engineering degree, and you're really, the leadership, and that maybe if you'd had those management skills, you'd have been more of a manager, and I kind of see that as maybe have actually taken you in the wrong direction. Do you have any comments?
Well, I don't think
it would have helped you or hurt you, or did you
I don't think it would have hurt. Yeah, I don't think that would hurt somebody. I mean, I'm not against any kind of formal education. My propensity to not be as much a manager is more of a personality trait. I can manage by discipline. I can discipline myself to manage, but I don't enjoy doing it, if you understand what I'm saying. It's something that I know it needs to be done, and my people need to be taken care of, and so I will do it for their sake. But if you said, what do you enjoy doing? I like solving problems and creating things. I don't enjoy figuring out if we've got enough computers and enough desks, and is there enough floor space for this, and how the bill's going to be played in this. And I can do all this. I can set the budget, and I can, but I just don't enjoy doing it as much. I don't know if I'm good or bad at it. And if I'd had some formal education, I might do it with less time and energy, which is probably what I would do. I would just, because my life at CSI has been where I do my management jobs sort of during the daytime, and then whatever I can steal in at night, I do the things that I want to work on that I enjoy working on, which tends to be, writing computer programs or solving problems or something. And so it's made me have to work a few more hours. But I will say I was in a unique position being able to provide leadership because Ron gave me that. I mean, he was the president, company CEO, he gave me the ability to influence him. I could have influenced him anyway, probably, but not, I mean, he gave me a tremendous influence with him. I mean, I'm still in a vice presidential role at CSI, but I have not nearly the influence with my current president that I had with Ron. And I think that's just individual styles. And so I'm still trying to exercise leadership. I mean, I spent 2 or 3 hours before I came over here in an engineering staff meeting where everybody was all up in the air about various things, and I'm spending 2 hours, and it was really kind of let's get our head on straight session, because a lot of accomplishing something, like I said, is keeping people focused on the vision, keeping the vision in front of them, keeping them not going off tracks, not getting into negative types of thinking, and doing counterproductive things. And a lot of that, like I said, it's certainly worth the 2 hours that I spent with them. But I'd consider that leadership, not management. I could have just said, guys, get to work and quit belly aching, and I can hear whining at home. Get off my back.
Okay. We do have refreshments downstairs on the second floor, and before we adjourn, let's express our appreciation again. That was exactly what I wanted to do. Let me get this.
Oh, yeah.